Okay, now we're going to tackle another factoring strategy or technique. As I said, we break it down into smaller parts and then we put it back together so we have a comprehensive plan on how to factor these polynomials. These are, if you look at the three examples, there are three trinomials once again. We want to go through our systematic procedure of trying to factor using our greatest common factor. Is it a binomial? If it's not, is it a trinomial? And if it's a trinomial, it must factor into two binomials. Now what's different about these examples that I'm showing you on this one is that these numbers in front of the y squared, the x squared, and the a squared, they're not ones. I'm going to flash back to our previous ones, and they were just one. So they said, let's start you off with some easier factorizations. Let's factor these trinomials in the form x squared plus bx plus c, where the number in front of the x squared, this implied number, is a 1. If you look at the new examples, they said, now let's try a different form of trinomial where they're of the form ax squared plus bx plus c. So this is the same, but the only thing we've changed is we put a number in front of the x squared. So that complicates our FOIL process a little bit. So then they go into this explanation of finding m and p with a product equal to ac and a sum of equal to b. Well, I'm going to work with you and I'm going to explain that in the video here and how we're going to do that, and then we're going to factor by grouping, which may be a little bit of a different skill that I'm not sure how much you practiced last year or even in Algebra 1s, but this is something that we can learn and take care of in this year. So okay, so what is this talking about? We want to find two integers m and p, and they seem like they come out of the blue and you don't even know what they're talking about. They want you to find two numbers so that when you multiply them together, they're equal to the product a times c. Now here's what they're referring to. A and c are the two numbers in your trinomial. You're going to multiply them together. AC is a product. But we also want this m and p not only to equal the product of AC, but we want it to equal the sum of b. So there's our b. So we got to put all of this information together. We want two numbers that we can multiply together to get the product of AC and get the sum of b. So we're going to organize our work here a little bit and try to put all the pieces of the puzzle together. The first thing we want to do is we really want to take and find the product of a times c. Now a is 3 and c is 4, so a times c is 3 times 4, which is 12. So 12 is our AC number. We want to find two numbers, and here's where the m and the p come in. Find two numbers that we can multiply together to get 12. So here's what we're going to do. We're going to organize it in a table, and the book shows us too, and it's kind of a nice way of looking at it. We got factors of 12. Now what are the possible factors of 12? And these are more or less our m and our p that we're going to be investigating to try to get AC. So we could do 1 times 12, we could do 2 times 6, we could do 3 times 4. And basically those are the only combinations of integer factors of 12 that we can use. On the other side here, we also want to look at the sum. We want the sum of the factors, which again are m and p. We want those to add up to b. So we want mp to equal AC. We want m plus p to equal b. So okay, let's go ahead and add these. So if we add the 1 and the 12 together, we get 13. We add the 2 and the 6 together, we get 8. We add the 3 and the 4 together, we get 7. Do any of these end up being our value of b? Well, here's our value of b. b is a 13. So it's telling us it's this combination that we want to use in our factorization. So we've kind of identified what we need. Now let's decipher the rest of this. So here comes the rest of the story. The rest of the story is, once you find that combination, you can write it as ax squared plus mx plus px plus c. So here's what I'm going to do with that. I found the m and the p that I wanted. M and p are 1 and 12. So we want to put down our ax squared. Well, that's our 3y squared. X and y doesn't make any difference what they use for a variable, but we start off with the exact same thing there. Then we use our m, and m can either be 1 or 12, so it's going to be plus 1, I'll put the 1 in there, 1y. Then we can put our plus, and we're going to have our 12y. And then we're going to use our value of c, and our value of c was 4. So plus 4. So here's our a, there's our b, there's our c. So our factorization is now 3y squared plus y plus 12y plus 4. And then they say to factor by grouping. Now, factoring by grouping means you want to group the first two in our polynomial and the second two in our polynomial, and then factor out your greatest common factor. So I'm going to pull out the greatest common factor. Between 3 and 1, the greatest common factor is 1. Between a y squared and a y, the greatest common factor is y. So I factor out a y. We factor out a y, we divide this by a y, we get 3y. We divide a y by y, it's an equivalency of 1, so it's 3y plus 1. So then plus, now we're going to do the same thing in this binomial, we're going to take out the greatest common factor. So what's the greatest common factor in a 12y and a 4? Well, that's a 4. 4 is the biggest number, divides into 4 and 12, and nothing goes into y. And there's no y to take out of our second term, so it's a 4, parenthesis. 4 goes into 12 3 times, and we have a y left over. And 4 goes into 4 once, and that's an equivalency of 1, so we've got 3y plus 1. So we factored out a greatest common factor, and now we're going to factor by our grouping. So here's our grouping idea. We can factor out a 3y plus 1 and a 3y plus 1 out of both of those expressions. We can factor a 3y plus 1 out of this term and out of this term. Now remember, when you factor, you're really dividing by the term that you pull out. So we pull out a 3 plus 1. We're going to divide this expression by 3y plus 1. We're going to divide this expression by 3y plus 1. And whenever you divide something by itself, a 3y plus 1 divided by 3y plus 1 is an equivalency of 1. And we're left with just the y in this expression here. Y is the only thing that remains. When we divide this one by our 3y plus 1, these terms are equivalency of 1, so all we're left with is a 4, so it's y plus 4. Now this is the factorization that we're hoping to get to, and that's what our desired effect was. So now we've got our factorization complete. To make sure that we have it correct, let's try our FOIL. Let's try our first term. Our first term together are 3y times y, or 3y squared. We take a 3y times a 4, our outermost, and that is 12y. We do our innermost two, and that is 1 times y, or just y. We do our last two, which is 1 times 4, which is 4. And then we collect our like terms, 3y squared plus 13y plus 4. Okay, now this is a technique the textbook is showing. It's got some value to it. That it eliminates some guesswork in separating these into the product of NP and the sum of NP. So that's the first go around. Let's take a look at it in the second example. Number 9, it fits into this classification, and here's what you're going to need to do. You're going to need to classify these things as you look at them. I've got a trinomial. There are 3 things in here. I'm going to look for a GCF. Is there greatest common factor in any of those? So will 3 go into 28? No, it won't go into 28. Can I pull out an X out of it? Nope. So there's no GCF. Is it a binomial? No, it's a trinomial. So there's no difference to 2 perfect squares. So now we know we have to factor a trinomial into 2 binomials. So we're going to go from a trinomial, and we're going to factor into 2 binomials. So tries factor to bis. But in order to do that, when it's more complicated, when you have a number other than 1 sitting in here, here's the technique that they're saying you should try. Take your A times your C. So take A times C. So we're going to take A times C, which is 3 times 32. Do the multiplication on that. That gives you a 96. So we want to be able to figure out what are all the factors of 96. But we also want to be eyeballing, and that's our M times P. But we also want to make sure that we're eyeballing, so we don't have to do extra work. We want to take M plus P. We want to make sure that gives us 28. We want it to give us B. So this is going to be the sum of your factors. Okay, so let's start with the most obvious factors. We can do 1 times 96, so 1 and 96. But 1 and 96 is a 97. That's not what I want. I want a sum of 28. So disregard those. We can do 2. Since it's even, 2 goes into 96. So 96 divided by 2, half of 90 is 45, and half of 6 is 3. That'd be 48. But 2 and 48 is 50. It's not a 28 like I want it to be, so I disregard those. 3 goes into 96 evenly. We know that's 32. We just saw that. But 3 and 32 is 35. That's not the pair that we want. 4 goes into 96, 4 goes into 9 twice, with 1 left over, 4 goes into 16 4 times, and 4 and 24 is 28. So now I've reached a combination in which I can get a product of 96 and a sum of 28, so now I know what my factors are. So I'm going to come over and I'm going to rewrite this. I want this 3x squared plus, now we've got 4 and 24 that we're going to write in here. I'm using this m and p value in this factorization process, so it's going to be 4x plus, and the next one's going to be 24x, then it's going to be plus our value of c, which was 32. Now we're going to group our first two and our last two. This is factored by grouping. I'm going to group those first two, and I'm going to group the second two, and I'll look for a GCF, greatest common factor. What's the greatest common factor of a 3x squared and a 4x? The greatest factor we can factor out is an x, and we left with 3x plus 4. Plus, what's the greatest common factor between 24 and 32? The largest number that divides into 32 and 24 is 8. 8 goes into 24, and 8 goes into 32, but 8 goes into 24 3 times, so it's going to be 3x, and 8 goes into 32 4 times, so it's just 4. Now, just like we had last time, this common factor shows up in both of our expressions. So we're going to factor out, we're going to pull out the 3x plus 4, we're going to factor out of our two binomials. And what's left when I factored out is an x and an 8, so x plus 8. And this is our binomial factorization for number 9. Second shot at it. Actually, I want to bring this back. I want to undo what I just did. I'm going to undo that. Okay. Example number 13. It's really example 3. I just pulled number 13 out of your assignment so that we can have a look at some more complicated ones. It definitely fits into this classification where we've got a value of a sitting here. It's not a 1. It's a trinomial. Should factor to two binomials. We can look for our greatest common factors. So is there greatest common factor in this trinomial? And I know that I got a 6, I got a 50, and I got a 16. I know that they are both, all three numbers, divisible by 2, so I can factor out, and I'm going to clean that whole thing up. I'm going to rewrite it here to get everything ordered. 6a squared minus 50ab. And hopefully I have enough battery to finish this, plus 16b squared. If I pull out the greatest common factor, I can pull out a 2. When I say pull out, I'm dividing everything by 2. It's going to be a 3a squared minus 25ab plus 8b squared. Now I can't pull out an a out of all three terms because there's not an a in this term. I can't factor out a b out of all those terms because there's not a b in that term. So all I can do is factor out a 2. I just took care of our greatest common factor. Okay, so now I'm still left with this variety where I've got something sitting in front of the squared term. So I've got that 3 to take care of. So now I've got this 2, and then we're gonna backpedal just a bit. I'm gonna take the 3 times the 8. I'm gonna do the old a times c trick, and I want to make sure that I find two numbers whose product is ac and whose sum is b. So I'm gonna take 3 times 8, which is our a times c, is 24. Then I want to look at all the factors of 24. So I can go 1 and 24, but that's a perfect. It's a 25. The sum of the factors is 25. So now I know my factors are 1 and 24. So I leave the 2 sitting out front, leave that alone so it's a separate monomial factorization. Then I want my 3a squared. Then I want to put in a plus a. Then I want to put in a plus 24a, and then I want to put in our plus 8 ab squared. So these have to be, ab and 424ab, and plus 8b squared. Then we're going to group the first 2 and the last 2. And we're going to factor out the greatest common monomial. So leave your 2 sitting out front. What can be factored out of a 3a squared and an ab? And we can factor out an a out of both of those. So take out an a, you're going to be left with 3a plus b. Do the same thing in the next one. What can be factored out of a 24ab and an 8b squared? And we can factor out an 8b, and we're left with 3a plus b. Now these two factors, just like they should do in factor by grouping, are the same, which means we've got the 2 sitting out here, leave it alone. We're going to factor out our 3a plus b out of each of these terms, and what we're going to be left with is our a and our plus 8b. So we've got a plus 8b. So then if you go back through and you multiply all this together, you should end up with your 6a squared minus 50ab plus 16b squared. So I'll try to do that in kind of a short fashion. This 2 sits out front. I'm going to multiply my final FOIL that we do here times 2. So I'm going to FOIL. That's a 3a squared. Then I'm going to take 3 times 8b, which is 24b. Then I'm going to take a b times a, which is ab. Then I'm going to take b times 8b, which is plus 8b squared. So that's 2 times. The only reason I'm waiting to multiply by that 2 is I've got some like terms that, well, they should have been sitting here. I didn't write my a in there. This was a 24ab, so plus 25ab plus 8b squared. Then we got to roll through with a 2. So 2 times 3 is 6a squared. Now I'm distributing a monomial. Double of 25 is 50ab, and double in 8 is 16b squared. So there's a factorization process where you utilize the factoring by grouping technique in order to factor probably the most complicated variety is when you have a leading coefficient that is not a 1.